Hello there, this is Ms. Nakayama, and today's lesson is 5.1 Angles of Triangles. I'm going to try to go through it quickly, but remember, if you need to slow me down, you have the ability to do that in your settings, or if I'm talking too slowly, you can speed me up. So let's go ahead and get started. First off, you need to know that you can classify triangles by either their angles, or their sides. So if we start off with angles, you have an acute triangle where all the angles are acute. You have an obtuse triangle where only one angle is obtuse. You have a right triangle where one angle is a right angle. And you have an equiangular triangle where all the angles have an equal measure. And you really need to remember that that measure is going to be 60 degrees. Okay? Now, if we classify them by sides, then a scalene means there are no equal sides. Isosceles means there are two equal sides, and equilateral means that all the sides are equal. All right, some triangle theorems that we have to know before we start working these problems. When the sides of the polygon are extended, other angles are formed, and the original angles are the interior angles, which are over here in red, and the angles that form linear pairs with the interior angles are the exterior angles, and that would be this. So interior, just what it sounds like, inside the triangle. Exterior or outside of the triangle, and they're formed by extending the sides of your triangle. And as I just said, they form a linear pair with the interior one. Okay, now, very, very important triangle sum theorem. Y'all already know this, that the sum of the measures of the angles is 180 in any triangle. So that says the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. All right, the exterior angle theorem you might not be so familiar with, and you will actually hear me refer to it sometimes as EAT, exterior angle theorem. And that says that the measure of each exterior angle is equal to, let me come back and highlight that, is equal to the sum of the two remote interior. So if you look at this picture, angle 1 is the exterior, and these are the two remote interior. This is an interior angle here, but it's not remote. It's next to the 1. So our formula in this case would be that the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3. Now, something we haven't mentioned before, we have corollaries, which are basically statements that can be proven easily with a theorem. And so the first corollary we have is a corollary to the triangle sum theorem. And it tells you that the acute angles of a right triangle are complementary. So in this case, it's going to say that the measure of angle A plus the measure of angle B is equal to 90. Now, you can see that C is 90 degrees, so if you added them all up, it would be 180. You can always use that. This just saves you a little bit of time in your math, and it's a little bit faster. All right, so classify each triangle by its sides and angles. So its sides, none of them are equal. Angles, they're all acute, because acute means it's less than 90 degrees. So this is a scalene acute triangle. Number 2, by its sides, I see this symbol here that tells me the lines are perpendicular, so you know that means it's a 90-degree angle. So it's a right triangle, and you can tell by the fact that it's 3, 4, and 5 that none of them are the same length. So it is again a scalene, but this time it is a right triangle. Okay, 60, 60, 60. We talked about that. All the sides are the same, so this is often referred to as equilateral. We just say equilateral. You can call it equiangular, but you need to know if you say one, you say the other in regards to triangles. Okay, next one, again scalene, because none of the sides are the same, but I do have one angle that's more than 90, so this is a scalene obtuse triangle. And the last one, number 5, I have a right angle, so it's going to be a right triangle, and I have tick marks here telling me that 2 of the sides are the same, so it is an isosceles right triangle. All right, number 6. Triangle ABC has vertices of 0, 0. That's down here. This is A. B is 3, 3. and C is negative 3, 3. Classify the triangle by its sides, then determine if it is a right triangle. So if I have to classify it by its sides, I need to go find the length of each of the sides. So this horizontal figure, BC, I just have to count my squares. So it has a side length of 6. Now, to find AB and AC, we've talked about this. You can use the coordinates and use the distance formula. But if you're on a grid, it's easier to see that this side length, look at this triangle that is made from one point to the other. And it has a side length of 3 and a height of 3. So if this is 3 and that is 3, then that means it is the square root of a squared plus b squared, which is 3 squared plus 3 squared. So that means the length of this is the square root of 18. And it's not the final answer, so I don't have to simplify that. Now if I go find segment AC, again I'm on a grid. Here is my right triangle. This side length is 3. This is 3. So I hope you can see that's the same thing. And this side is square root of 18. All right, so that means we have figured out that it is an isosceles triangle. Now we have to decide whether or not it's a right triangle. Well, we have the rise and the run right here. And this is a positive one. So I've got the slope of segment AB is 1. And the slope of AC, segment AC, all right, it's falling, got the same rise and run of 3 and 3, but this time it's negative 1. And if the product of these two is equal to negative 1, and remember if we multiply the slopes together and we get negative 1, then we know that those two segments have to be perpendicular. So we also know that A is a right angle. So we have classifying by sides is isosceles, and yes, it is a right triangle. So we have an isosceles right triangle. All right, solving. Find the measure of the variable and each acute angle. So 47, 58, and x in this triangle, all the angles add up to 180. So remember, got to write that setup equation. If you don't write anything else, write the setup equation. 47 plus 58 plus x equals 180. So I'm just going to add up 47 and 58 and subtract it and find out that x is equal to 75. So that is my missing angle. Number 8. I have, that's not missing angle, so I have to do it. All right, so this one, I've got 70 plus 60 plus 8x plus 2. Those are all three of my angles. All three angles add up to 180. So 8x is equal to 180 minus 132, which is 48. Divide both sides by 8, and x equals 6. That makes this other angle. So how do I find this angle? Is I take 6 and I'm plugging it in here for x. 6 times 8 is 48 plus 2 is 50. So that means this missing angle is 50 degrees, which of course you can check. 70 plus 60 plus 50 is going to give you 180. All right, number 9. That one, you can use all three angles, but I like the corollary because it's shorter. So I know that when I have a right angle, the other two angles have to add up to 90 degrees. So that's going to give me 3x minus 1 plus 31 equal to 90. And 3x is going to equal 60, and x is equal to 20. So I have to go plug that in because I got to find, I already know this one's 31. So plug in 20, 3 times 20 is 60, and 60 minus 1 is 59. So that other angle is 59 degrees. Number 10. All right, look at this guy. So I'm going to go over here to this triangle, and I'm going to use these angles first. And I'm going to say that 43 plus 57 is equal to 100. So that means that this missing angle, the third angle in this triangle, has to be 80. And I know you know vertical angles, so the angle over here is 80 degrees. So my setup equation to find x is going to be x plus x. Whoops. Go away. X plus x plus 80 equals 100. So 2x, equals 180. X plus 80 equals 180. Subtract 80, add my x's, I get 2x equals 100, and x equals 50. So both of these are equal to 50. Now, y'all, if you're getting this, you should go and work it by yourself, and then turn the video back on. Go finish the notes, and then go look at it, watch it really quickly, and then you know that you know what you're doing, and then your homework will be that much easier. Okay, this one, number 11, I don't know all of the angles inside, but I do know an exterior angle. So this is an example of the exterior angle theorem, and I'm going to say that 15x plus 5 plus 22x plus 4 has to equal 120. These are the two remote interior angles to this exterior angle. So if I add up my x's, I get 37. 120 minus 11 is 120 minus 9 is 111. And 111 divided by x is 3. So I have to plug 3 back in. 22 times 3 is 66 plus 4 is 70. That makes that 70. And you can go ahead and subtract 120 and 70 and find out what this one is. But you can also check yourself by plugging 3 in. 15 times 3 is 45, plus 5 is 50. So we did it both ways and got the same answer, so we know that we're doing things right. All right, number 12. Not the EAT, because I don't have an exterior angle. I do have all three angles, because I know this is 90, and if that's 90, I'm going to say I know these two add up to 90. So I'm going to have 3x plus 2x equals 90, so 5x equals 90, and x equals 18. So I got to go plug those in. 2 times 18 is 36. 3 times 18 is 54. So that is the measure of my two angles. All right, turn your papers over. Find the measure of the exterior angle and any missing acute angles. So here, my exterior angle, x is equal to, excuse me, x is equal to 21 plus 34. And when you add those together, you're going to get 55. Number 14. All right, my exterior angle is 11x plus 2. My two remote interior means they don't make a linear pair with that exterior one. So that means that 5x plus 10 plus 58 is equal to 11x plus 2. So I'm going to combine my 6's on the right side, my x's on the right side. 11x minus 5x is 6x. And then 68 minus 2 is 66. 66 divided by 6 is 11. Now I have to go find the missing acute angles. So I'm plugging 11 in for x. 5 times 11 is 55, and 55 plus 10 is 65. So that angle is 65 degrees. Number 15, here's my exterior. Here are my two remote interior. So my exterior angle, 3x plus 6, equals 24 plus 2x plus 18. So if I collect my x's on the left side, I have just 1. And then if I take my 6 over to the right and combine like terms, I'm going to get x is equal to 36. So 2, all right, we already know that one's 24. This is the missing acute angle. 2 times 36 is 72, and 72 plus 18 is 90. So that's a 90-degree angle. All right, number 16. Here's my exterior. Here are my two remote interior. So I'm going to say that my exterior, 3x plus 25, equals 2x plus 65. Collect my x's on the left and take the 25 to the other side. I'm going to get x equals 40. And I'm going to plug that in. 2 times 40 is, of course, 80. So this angle is 80 degrees. All right, we kind of have an angle chase here. Find the value of each numbered angle. And if you know me, you know I like to do this on the angle chase and then go fill in the blanks. So I know that angle 1 is an exterior angle. This is an exterior angle to these two remote interior. So that means that angle 1 is 140 degrees. I add those up. which means that the interior angle, the one left in this triangle, is 180 minus 140, and that's 40, which means that 2 is 40. And I can figure out that 4 is a linear pair with 105. So 4 is 75, which of course means this is 75. And so now I can add all three of these add up. That's of course 115, and 180 minus 115 is 65. And what else do I have left? I have 5, and 5 is an exterior angle with 40 and 75, and that of course makes 115. So we have all of our angles. 1 is 140, 2 is 40, 3 is 65, 4 is 75, and 5 is 115. All right, number 18. Find the value of each variable. So you got to get used to looking at these triangles. I'm looking at this first one here on the left side, and I'm going to say that 28 plus 85 plus x is equal to 180. And so that's going to give me x equal to 67. My y, I know that if this is 67, then 67 plus y has to equal 180. And that means that y has to equal 113. So now that I know y is 113, I know up here I have 17. So that means that, actually you could do a couple things. So, figure out which one you think is easier. If it's 113 plus 17, and that to get 180, or you can do the remote, see the exterior angle of x is equal to the sum of the two remote interior. That's what I see. I just like to keep my numbers smaller. So I did 67 is equal to 17 plus z, and z is equal to 50. Whichever one. You should get the same answer no matter which way you do it. The beauty of math. All right, let's look at number 19. So I'm going to do y first because I'm looking at this triangle right here. And I see that's 90, and I see up here is 32. So if that's 90, then 32 plus y has to equal 90 because that's our corollary. The acute angles of a right triangle are complementary. So that means that y is equal to 58. And now that I know y is 58, I have this is 27. So look at this. If you have any trouble, nope, come here. Look at this triangle here for the second one. Because now that I know that x is a exterior angle to y and 27. So that means 27 plus 58 has to equal x. And so x equals 85. Number 20. All right, if I'm told this is 75, then our linear pair means this angle right here is 105. And what else do we have? We know that, what is x, y'all? If this line is parallel to that line, then x is an alternate interior angle with 43. So I know that x has to equal 43. And then I'm going to use my exterior angle theorem of 75 equals 43 plus y. That's the exterior angle equals the sum of the two remote interior angles. And so that means that y is equal to 32. All right, last problem. The measure of one acute angle of a right triangle is 1.5 times the measure of the other acute angle. Find the measure of each angle. Okay? The key that you might have missed, you're going, wait, they only gave me 2 angles and I need 3. But the key you got to remember is that they told you it was a right triangle. And if it's a right triangle, those 2 angles add up to 90. So my first angle is going to be x, and my second angle is 1.5 times x, and that equals 90. So 2.5x equals 90, and x equals 36. So my first angle is 36, and 1.5 times 36 is 54. So my 2 angles are 36 degrees and 54 degrees. And that's all I have for angles of triangles. You will use them a lot solving all kinds of situations, even when you get out of geometry. So, thank you so much for watching. Please don't hesitate to email me or come see me if you have any questions. Y'all have a great day.